this Unit 4B practice, stating if polygons are similar and trying to find missing pieces or a scale ratio, and a whole lot of problems here, and solving some equations. I'm going to be using a tool called Graspable Math. In order to get to that tool, you could just go to math.new, and this is like DudaMath, but it has, I think, a little bit cleaner kind of process where you can see the steps a little more clearly. Okay, so let's look at a few of these pieces. I notice that I have pairs of shapes, and what I need to do to compare them is to compare corresponding sides and see what their ratios are. You might be asking, well, how do I know which pieces are corresponding? The biggest clue is to kind of look at the side lengths and see if they are the longer, the shorter, or if it's a triangle, if it's the medium side. So let's look at this first one. Number one, it has a side length of 16 and then 14. And then the other two are just matching pairs for that. So 16 is the longer and 14 is the shorter. Over here I have 21 and 24. So 24 is the longer and 21 is the shorter. The way that I would compare it is I'd compare short to short and long to long. And if I get the same ratio, that means I have a consistent ratio across all of those shapes. And then what I'm also going to be looking for is some of the congruence in the angles. So let's take a look at this first one. So the first one, I have 14 and 21. So let's go ahead and give ourselves that angle here. I'll type into this input box 14 divided by 21. If I just mark that, now if I try to click on it, it will actually reduce or simplify or write an equivalent form of that fraction. I see that it goes down to 2/3. Let's try another one. So 14 over 21 gives me 2/3. Let's see what 16 over 24 gives me. That also simplifies to 2/3. So what I noticed there then is that each of those pairs simplify to the same scale ratio, 2/3. So that's good news so far. Now here's the other thing that's kind of interesting. I see that I have 45 degrees here and 140 degrees there. Well, on a shape like this, because of these parallel lines, I would have angles that add together to 180, like same side interior angles. Another way of thinking about that is I have these angles here, and up in this corner is 45, and in this corner then I should have 135. Now that gives me a little bit different shape, because in the other one I have a 140 up in the corner, which would mean that this one over here is 40, because it has that same side interior kind of pattern, and we'd have a 140 there. So this is 140 here and 40 here. Now because of that pattern not really matching up, I would say that these shapes are not similar because they have some different angle measures. Even though they have the same scale ratio, they have some different angle measures. So for number one here, I'm going to say not similar. We'll even write it down so we know what we were saying. So this one here, not similar, because angles don't match. The angles would have to match, and the ratios for the scales would also have to match. Okay, let's see if we can erase all of this. Just do a new screen. And let's look at these pieces now. I notice that there's congruent markings in the angles, so that means the angles do match. I just need to check the scale ratios to see if those also match. I see that I have a 10 for my shortest side, or not my shortest side, but 10 for my short base and a 14 for my short base. And then a 14 for my long base and a 21 for my long base. Let's see how those numbers match. So if I have 10 divided by 14, that would simplify to or be equivalent to 5/7. Let's check 14 over 21. And that would be 2/3. So those are not equivalent scales. One is a scale of 5 to 7, and the other is a scale of 2 to 3. So 10 to 14 is 5 to 7, and 14 to 21 is a scale of 2 to 3. So again, I would say not equivalent, but this time because the scale ratios don't match. Not equivalent, scale ratio mismatch. Or I shouldn't say not equivalent, not similar, because of the scale ratio mismatch. All right, let's go to another one. We have rectangles. Rectangles will be similar so long as the scale ratios match up. Let's see what our scale ratios are here. I'm going to erase these. We'll start again. And we have our short side is 12 and 8. So let's do that ratio. We'll do 8 divided by 12. Let's see what we get for our ratio there. That's a ratio of 2 to 3. And then our other ratio is going to be, so we did 8 to 12. We want to check 12 to 15. 12 to 15. And if I were to click on this one, it's a ratio of 4 to 5. So again, not similar because the scale ratios are different. For the last one, I'm really hoping that this one is similar. Let's just check it to see what we can get. So we'll erase those. We'll try something new. We're going to do our short side to short side. That would be 4 to 16. That's going to be a ratio of 1 to 4. Let's check our other ones. 8 to 32. That should also be 1 to 4. So that's consistent. That's good so far. How about 6.1 to 12.4? 6.1 divided by 24.4. So I type those in and I check them. And it is 0.25 or the same as 1/4. So if I click on these, double click on them, I can see that they get a decimal 0.25. So that is going to be a consistent scale ratio. 4 is similar. So not similar for 1, 2, and 3 for different reasons, and 4 is similar. Now let's take a look at 5, 6, 7, and 8. We'll refresh this page. See if we can start over. And for these ones, what I'm looking for is it says find the scale factor of the smaller figure to the larger figure. So what we need to do is match up some corresponding sides of the smaller to the larger. I notice that I have a 12 and an 8, so the 12 is longer, the 8 is shorter. Similarly, over here I have a 12 and an 18. So the 8 is the short side on the small figure. That would be the 12 on the short side on the large figure. So I would then find my ratio to be 8 to 12. Now that is a correct answer because it doesn't say that we have to rewrite it in simplest terms or in smallest numbers. But if you did want to double check it with like a computer algebra system, it would be 2/3. The last thing it says here is to find the scale factor of the smaller, or let's try another one. We got 40, 40, and 32, 32. So we're going to take the smaller number, in this case 32, to the bigger number. So we just do 32 divided by 40. That's our ratio. And if we were to write it in equivalent form, it would also be equal to 4/5. Now let's look at 7 and 8. I notice on 7 that I have two sides that are equal and then a third side that's longer. Again, I have two sides that are equal and a third side that is longer. I just need to match up two of the corresponding sides. This 14 is the long side. That would match the long side on the other one. So I'm going to write my ratio as 14 divided by 35. That would be an answer, but if I needed to rewrite it in equivalent form with smaller numbers, I would say 2/5. So for each of these, let's write out some of these answers. We have for this first one, it was a 2/3 ratio. And for this next one, it was a 4/5 ratio. For this one, we had a 2/5 ratio. And I'm going to go ahead and do the last one here as well. I notice that I have an 8, a 24, an 18, and a 12. I'm looking for corresponding sides. I notice that the 12 and the 18 seem to be the longer kind of base, parallel side there. So those are the only two that are matching, because this 24 would be matching with something here for these longer sides. This 8 would be matching with something here for the shortest side. So it's this medium side that's the only one that I have something from both shapes, the smaller shape and the larger one. So then for that scale ratio, it'd be 12 divided by 18. Again, you could rewrite it in an equivalent form, and that would be 2/3 for that one. Okay, let's do a few more of these shapes. Now we're going to start to solve for some of these missing pieces using equations. This graspable math whiteboard tool will be quite useful for that. All right, so we have a question mark here, and we'll call that an x. What we want to do is set up an equation where we have a fraction equal to a fraction, but we got to match up the pieces. This question mark, let's see what we have here. The shortest side is going to be matched up with the shortest side over here, this 8. So I know that I have 4 divided by 8 for one of my ratios, for the small figure to the large figure. That tells me that it's kind of double. And now if I look, this 5.4 is half of the 10.8, so doubling that gives me the 10.8. Over here, this 10 must match this question mark. So I'm going to say equals x divided by 10. Once I have this, now I can do some things to try and get x by itself. Well, for one, I could simplify the 4/8 to become 1/2. And I can multiply the 10 over to the other side. Now it'd be 10 times 1. And then I can say 10 divided by 2 is 5. So x, or the question mark in number 9, is 5. Let's take a look at number 11 and see what we can do to set up something for that one. So again, I have the long side this time is an x, a question mark. So I need to match it with the long side of the other rectangle. So I'm going to put an equation here, and I'll put x divided by 14, because that's the two long sides matched up. Now let's get the two short sides matched up. The short side from the smaller figure is 5, and the short side from the larger figure is 10. So I'd have 5 divided by 10. Now I can go ahead and multiply both sides by the 14 to give me 5 times 14 divided by 10. I can click on the multiply to figure out how much that would equal to. And then I can click on the divide and figure out that x equals 7. So for number 11, x equals 7. All right, now we're going to do a couple more examples to finish. And on these examples, we have to actually solve for x, but it has a little bit more going on with the x value. So I'm going to do numbers 13 and 15. For number 13, I noticed that I have like a 5 and an 8. And it looks like those are not the shortest sides, but they're the two sides here and here. And then the shortest side has nothing on it for both of them. So there's nothing on the shortest side for each one. So I have this 5 and 8, and then the side between them is what matches the other side between. So we have two sides with a side between. So x minus 1 and 35 are going to go together. So when I try to set this up, I'll have x minus 1, but I should put it in parentheses, divided by 35. So that's this kind of medium side matched up with this medium side here. Let's do the long side. So I know that 8 is the long side over here, and 40 is the long side on the other one. So I can do 8 from the smaller figure compared to 40 from the larger figure. So when I'm building these fractions, I'm aligning a couple of things. One, I'm aligning corresponding sides. But then in the other direction, I'm aligning kind of both of these come from the small figure and the other two come from the large figure. So let's see what we can do with this equation. Well, first I could divide this 8 and 40 to rewrite it as an equivalent fraction. That's just 1/5. Now I want to get rid of this 35, so I was trying to think, how could I multiply it? So if I multiply both sides by 35, it's going to take it out of the denominator on the left side. I'll click on this multiply sign so that it just says 35 instead of 35 times 1. And then I'll click on the divide sign to see what happens there. 35 divided by 5 is 7. And now I need to add this minus 1 over to the other side, which makes it plus 1. And 7 plus 1 for the final step to simplify there is 8. So for this, x equals 8. The length of this side would be 7, but x equals 8. All right, one last one that we are doing here, and I see a few things going on. I see that I have a short side, the long side, and then I have a medium side. When I look at these three pieces here, I have this 15 is the short side. So I know that for one of my fractions, I'm going to have 3 to 15 because that's my two short sides put together. And then let's try to match up something with the 3x. Well, the 3x is going to be something divided by 3x because the 3x goes with the 15. And then what would be the one that matches it? I either have 6 or 5.4. It appears that this is the longer side. It's got a little bit wider angle between the 3 and the 6 and the 15 and the 3x. So that means I'm going to match it with the longer side on 15, which in this case is 6. Let's see what we can do with it. I can see if I can make an equivalent fraction with 3 over 15, and that just turns into 1/5. At this point, I'm going to cross multiply. So I'm going to multiply both sides by 3x. So I'm going to say times 3x for both sides. Now what I did there is I clicked on the equal sign, and then I said multiply by 3x. And 3x over 3x I can divide, let's see, oh, okay, I can divide this over here. That's a lot going on. Let's go back. I'm going to go back to that line. So if I multiplied both sides by 3x, And I'm going to multiply this side by 5. So I have 15x, 15 times 6. The x's will finally cancel out there, and I can say 90 divided by 3 is 30. So 3x equals 30. There's a lot going on there that got me to 3x equals 30. And I can divide by 3 and finally get to x equals 10. So over here, x equals 10. There are other ways that I could have solved that, but a lot of it is just trying to move pieces around or multiply or add things to both sides where I can get x by itself. That's the end of this video, just kind of showing a few examples on how to do all of these.